Hi everyone, and thanks for watching this demo. In this video, I'm going to show you how to securely connect ggscout to the GitGuardian SaaS platform using ggbridge, even when ggscout is deployed in a completely isolated environment with no internet access. So as you can see on this diagram, this is a common setup in high security environments, sometimes called air-gapped, where outgoing connections are not allowed. So in this case, ggscout cannot communicate with the GitGuardian SaaS API, so it can't send its secrets inventory. To solve this problem, we will use ggbridge. ggbridge creates a secure communication channel between ggscout and the GitGuardian platform without opening the internal network to the outside. So ggbridge is deployed in a network zone called proxy network on the diagram, which is exposed to the internet and that ggscout can access and opens a WebSocket tunnel to the GitGuardian platform. This tunnel is secure and authenticated, and it is started from inside the infrastructure, so no inbound traffic is needed. Once the tunnel is established, ggbridge makes the GitGuardian API available through the private internal URL. So for ggscout, it's like the API is hosted inside the company network, even if the traffic goes to the GitGuardian SaaS. So this setup keeps the private network isolated while still enabling the integration with GitGuardian. For this demo, I deployed ggscout using the Helm chart on my Kubernetes cluster in a dedicated namespace that has no internet access. ggscout is configured to collect secrets from my HashiCorp Vault Secret Manager and send the inventory to the GitGuardian platform using the public endpoint. At this point, if I try to run the ggscout ping job, if I check the logs, as you can see, it cannot reach the GitGuardian platform. The connection is refused. So now I'm going to deploy ggbridge. So first, from the GitGuardian dashboard under the security settings, I need to create a new bridge on the server side. We call it ggscout. All right, then I can see the parameter of my bridge. I can download the client certificate bundle to authenticate with the server and copy my dedicated endpoint for configuring the client side. Then I'm going to deploy the ggbridge client using the Helm chart. So first of all, I configure the hostname of the server I want to connect to, copied from the dashboard earlier. And as you can see, I've configured the Helm chart to create a web tunnel between the client and the server and expose a private API endpoint using ingress resource that will redirect the traffic to the public GitGuardian API endpoint. Now we are ready to deploy ggbridge client by running Helm upgrade. So let's wait a few seconds for the connections to be established between the client and the server. All right, we are good. ggbridge is now connected. And if I check ingress resources, I have a new ingress available with my internal hostname. Now I'm going to change the GitGuardian API endpoint in the ggscout configuration to use the internal API endpoint exposed by ggbridge. I replace .com by .local. Then I will run a Helm upgrade to apply the new configuration. So now let's try rerunning the ggscout ping job and check the logs. Okay, we have now access to the GitGuardian API through the internal API exposed by ggbridge. So now let's try running the inventory job and check the logs. Okay, Everything looks good. The inventory seems to have been sent successfully to the dashboard. So let's check the GitGuardian dashboard to see if all the secrets from my vault are showing up correctly. So under the NHI Governance inventory, okay, all my secrets are properly listed, so I can see the my secret from vault.gitguardian.local instance. That's all for the demo. Thank you for watching.